So I think we can right away start with getting started with algorithms. This is your first class in module 2, and yeah, this is going to be a lot of theoretical to learn concepts and all, more of coding. There will be a lot of theoretical concepts like your when to use what is this algorithm, asymptotic notations, how to write an algorithm. The batch like which I've taught previously, they know what is an algorithm because they have written it in the project. In one of the event I conducted, they have written an algorithm. I'm gonna again explain how to write an algorithm, and something called asymptotic notation, asymptotic analysis. I'll also talk about this. Yeah. So let's start. What is this data structures? Let me show you one small image and ask you a small question. Mm, okay. So you may think why I'm asking this kind of doubt, but I'll tell you. I will let you know. So here, I'll zoom it in. Think of a scenario like if you are not able to find this image good, you can think of an image in your mind. Think of a dirty desk, like a desk, a computer desk, which I have right now, a computer desk. Think of a dirty desk, like very messy things like here and there and all. Think of a neat, clean, organized desk. Which one do you prefer? Do you prefer a messy one, or do you prefer an organized one? Like it can be applied to any scenario. Usually you like a messy organization or a neatly organized thing. We always prefer an organized thing. Why? Because it is easy to handle. If you think anything that is organized is easy to handle, because if you want something, you can just right away, you know where to pick it up, where to put it. So you know that the time that takes to work on a neat desk is much more less than compared to a messy desk. Because for a messy desk, if you move your mouse, something will be we'll be touching something, keyboard won't be good and all. So the time taken for an organized desk is always better, and it takes always less time. That's what I wanted to tell. The same thing applies for your programming also. The same thing applies for your programming too. In programming, what happens is there is a concept called data structures, not algorithms. There is a concept called data structures. Sir, what is this data structures, sir? Data structures is nothing but the way you handle your data. The way you handle your data is nothing but your data structures. That's it. Very simple. The way you handle your data is nothing but your data structures. Sir, why these data structures is needed? Without these data structures, can I code or can I not code? You can code without a data structure, without using like not even one data structure. You can solve a lot of problems. But the thing is, your code looks so messy, and there may be a lot of bugs included in your code if you don't use data structures. That is what happens. For example, if you want to use different types of data, obviously you will be using an array. But without an array also, you can write your code. It is possible to write code without an array. I have given this example previously. Like if we have 1,000 students, you can write student 1 equal to Monish, student 2 equal to Venkul, student 3 equal to Vishnu, something. You can just create different variables, and you can do that. Your code will work. But it is so messy. The code is so messy, no one can work on that code. And as a programmer, we should not write that kind of code. We should write as organized code as possible. As organized, yeah, using object is much more better than an array in this case. So the way you think, the way you handle your data is nothing but your data structures. And now, sir, okay, sir, now you said data structures. What is algorithms? Algorithms is nothing but, for example, uh, think of a team, a development team. I and my colleague is there. If I want to talk about the a particular code, do I talk with him like, array, for I equal to 1, I less than n, I plus plus, I 20, like that? Do Is it a normal human talk? Do we talk like that? Am I talking to you like that? Like, if I want to talk about adding n elements in an array, do I say I equal to n prompt take n? Do we speak like that? We don't talk like that in real life. We don't talk like that in real life. So algorithm is nothing but how you present your logic of your code. How you present your logic of your code. It usually will be in a plain English. It usually will be in a plain English. Like, from I equal to 1 to 100, we will increment I, and also we will add I with its previous value. That is how we will write an algorithm. That is why how we discuss in real life. So that is nothing but an algorithm. Converting your syntactical code to normal English and presenting it is nothing but an algorithm. Usually, now from your knowledge, answer me in the chat, which comes first, actual code or algorithm? In your mind, which one do you have to think first? You have to think algorithm first or coding first, like actual code, syntactical code? Yeah, algorithms comes first. Always algorithms comes first. Why? Because even when you see a question on the screen, your mind automatically starts to think in English, like your native language or English. It doesn't automatically think in JavaScript and all. First you will know, okay, this is what I have to do, this is what I have to, here I have to increment, here I have to do a loop, here I have to use a decision statement. Then after you knowing the algorithm, maybe you will, some developers write with pen and paper. Even I am that kind of developer. First I write it in a pen, on a paper, like what I have to do, and then I will start coding. That is a good process actually. Okay, you all understood what is an algorithm. Yeah, exactly, a blueprint of a program. That's exactly right. Even top someone mentioned it. Blue Shivakumar mentioned it. Yeah. So that is all about your data structure and just what is data structures and what is algorithm. This is what it is. And by using these data structures, a company Amazon reduced it. I don't know if you heard this or not. For Amazon and Google, there are such big companies, even milliseconds matter to them. For example, if I open now Amazon.com, and it happens in real life, it happens. If I open Amazon.com and if within 3 seconds, if my web page didn't load, I will just close it. I will just close it. I will lose my interest in shopping. It happened to me many times. So I think of something to buy. I open Amazon. If it doesn't open in just 3 seconds like that, I close it. I usually close it. I lose my interest in buying that product. Maybe after tomorrow or like that I will open. But right and then I will lose the interest. And this was a survey conducted by Amazon, and it was actually real. Lot of customers, when they see something is getting lagged or taking time, they just close it. They just close it and they won't use it again. So Amazon used some data structure concepts to make their loading screen faster, and that is the reason sometimes even if your internet is not working properly, and if you open an Amazon app or something, Amazon uses something called cookies and cache. It stores some data in your mobile phone already. So even if the internet is not so good, it uses that cache and cookies to show something. It may not work properly, but it will show some products. It will show some products right and then, so that you won't lose your interest. Like that, it saved billions of money. This was in 2016 or 2018, I guess. I don't remember properly, but it was a fact. Even the Google has done the same survey. Okay. What is the data? What is okay, there is a doubt. What is the difference in data structure and algorithms? Data structure is how you handle the data. Algorithms is how you present your code. Here in data structures, we only talk about data. How you store it. For example, if you see there is a player, the same player you can store it in array. You can store it in a linked list. You can store it as an object. You can store it as a variable. You can store it as a mapper. You can store it as a sector. But the best way to store a player of this kind of data is an object. It is an object. So how you store a data is your data structure. How you like how you present this code, like the logic of this code, the logic of complete code, not data, but the complete program is your algorithm. I hope all of you understood what the difference between a data structure and algorithm, because these both are two different things. Algorithm is different, the data structure is different. If anyone have not understood the difference between algorithm and data structures, put it in Q&A. You can ask me in Q&A. I will help you out. Unfortunately, Mr. Today's class, is there any change in my class? Devi Prasad, you can see the recording. I think recording would be fine for you. Yeah, project review, I'll do it. Divya. Yesterday, really didn't get time. It was full busy. So I'll see that. I'll give my own review. I have already sent your projects to Alma Better. They are reviewing it. I will also review it. Could you explain again about Amazon issue? Okay, the Amazon issue is nothing but, again I'm explaining. It was a real issue happened in real life. Whenever users are trying to open Amazon, for example, we do this, right? Amazon.com. If it is taking some time, right away I'm getting the products. But if it is taking some time to load, for example, if it is taking 3 seconds to load the entire website, usually customers lose interest on the website. Usually customers lose interest on the website, and they right away close it. So when, like, if I close it, I'm just one customer. But what if millions of customers close that? Amazon loses billions of money. So it used data structures, and it makes sure that if anytime, even if the internet, if the customer internet is not so good, but if he opens Amazon.com, he will be getting some or the other products on this web page. That's how, by using data structure, they have fixed it. So by this way, they have they have uh, helped themselves, uh, like with billions of money. They did not lose billions of money because of this small thing that they have done. Uh, Data structure is not clear. Okay, I will explain data structure again. So let's take. Let me open my VS Code. This is a Python code. I'll show you something. You tell me which is good and well. Okay. Let's say I'll present same data in different formats. You tell me which one is good. Let's name it student array, because this is an array. Student object. I'll tell you what is data structures now. Maybe you'll understand better. Maybe age, anything 22 or something. Um, okay, let's take these two. These two is enough. You'll understand. Uh, Deepak Kumar or anyone here, or I will add few more numbers. Let's say 98. Okay, let's say 98. Maybe this is marks. Okay, the same data. Here is the same data, Monish Venkul 2298. This is also same data, Monish Venkul 2298. I have not changed anything. I have not touched anything. The data is same. But you tell me from the chat, you tell me in these two, which one is better? Which one is better? Do you use student array or do you use student object to handle this data? Monish Venkul 22 and 98. Which one do you think is more good, more presenting itself, more precise and all? And there is no right or wrong answer in this. There is no right or wrong answer. It's personal thing. If you ask me, I will go for the second one. If you ask me, I will go for the student object. Why? Because if I don't show you this, can you tell me what is this 98? Can anyone tell you? Don't look at this object. Because if I have written marks here, you know that it is marks. If I have not shown you this, do you know what is 98? What is 22? Can you know that at least? There's no way to know what is 22, what is 98. Maybe we may think that Monish is his first name, Venkal is his second name. What if this is his father's name? We don't know. We don't know what is that data. There is no meaning for that data. So this kind of this, if you, that is what data structures tells you. Data structures is nothing but, data structures is a concept of different type of things like objects, linked list, arrays. It gives you a lot of concepts. It gives you a lot of concepts and tells you to use which one you want. It tells you to use which one you want. Array, I will be giving you a lot of things, like I'll be giving you array, object, linked list, set, map, the trees, graphs. There are like lot of data structures. You use which one you want and make your code better. That is what data structures is telling you. Here in the object, if you see, object defines every element. Like Monish is okay, Monish is first name, Winkle is last name, age is 22, marks is 90. That is how it defines. So it will be easier for us to work on this kind of data than this kind of data. Sir, but if we declare a separate array, what is the use of declaring a separate array again for first name, last name, age and 22 marks and all? Why to have two arrays when you can have, why to have two data structures when you can fit the same thing in one data structure? Like instead of again having let student data define array equal to first name, last name. Instead of doing like this and linking this Monish with first name, Winkle and last name, we can directly use this student object. We can directly use an object. Here object is best, because instead of writing like this and linking again, it's waste. So that is the thing. Means array is not useful and not good. No. That is based on the scenario. That is based on the scenario. Okay, let's take another example. Let fruits. Let fruits equal to mango, apple, orange. Enough. Okay. Let fruits equal to, now you will understand. This is fruits array. Actually, I'm covering a lot of topics now. These all are there in your material, in your alma better material. Fruits object. Fruit 1. Mango. Fruit 2. Apple. Fruit 3. Orange. Now think and answer me. Should I use array for this kind of data or object? Which one is better? Array. Here you will be using an array. Here if you use an object, it is waste. because arrays are much more like size complexity wise and complexity wise, arrays are much more simpler. So in this kind of scenario, why are we writing fruit 1, fruit 2, and fruit 3? By just looking at this data, we'll understand it. This is the first one, second one, third one. We know that. There is no need of using an object here. Now, did you get my point? It's not like which one is better and which one is not better. That's not the point here. What to use? What to use, when to use. That is the point here. Did you get it now? Like some of you are asking code size and all. That is what that is the trade-off. You have to maintain your size of the code better. You have to maintain the time of your code better, and also we have to make the data organized. That is why a software developer or a guy working in Amazon gets that much of money as salary, because he has to think in different ways to do a small kind of code. You have to think, you cannot just simply write a code. That is the reason, even for smaller projects, companies like Amazon, Apple, Google, they take 6 months, 1 year, 2 years. This is the reason. Even to write a simpler code, they think it in thousand ways how to make it much more simpler. That is the reason. I'll just clear some Q&A and we'll move on. This one I answered. Sir, is algorithm implemented in front end or back end part in real world applications? Algorithm, again, I'm saying algorithm is not something that you code. It's a concept. It is a conceptual thing. It's not a practical thing. It's a conceptual thing. I'll talk about algorithm. If for example, this is there, right? This is the code. This is the code. You know how the algorithm of this code looks like? Algorithm. Algorithm usually starts with something called start. We usually write like that. It's a good practice. Start. Second thing. Store, mango, apple. Oh, sorry. Mango, apple, and orange in an array called fruits. And that's it. This is an algorithm. This is an algorithm. I hope you are getting my point. This is an algorithm. Algorithm is a conceptual thing. It happens in your mind and you put it in your paper or somewhere. Algorithm is this kind of thing. Just writing it in a plain English. This is an algorithm. It tells what to do. It doesn't tell it doesn't tell the computer what to do. It's for human understanding. So if I'm a new guy in the company, if I come and see store mango, apple, orange in an array called fruits array. Okay, in this one line, I can what the information I get. I am getting an information like I have to create an array. That array name has to be fruits array, and it should contain data of mango, apple, and orange. That is what exactly I am doing in line number 1. That is what exactly I am doing in line number 1. That is an algorithm. It's server side processing or database. Wherever logic is there, we use algorithm there, but algorithm is a conceptual thing. It's not a real life practical thing that we do it in the computer. What way it helps, because loading of pages surely depends on server as per my knowledge. And please correct me if I'm wrong and I don't have any. Sajot, it's a good question. It's a good question, Sajoti. One of our friend is asking, sir, even if I use data structure, sir, how it will help my app, because it is purely on server side. For like all of you, if you're having this doubt, in your mobile phones after this class, just bring that navbar down, off your Wi-Fi, off your mobile data, open Facebook or Instagram. Open Facebook or Instagram, off your like put it in airplane mode if you want. Put it in airplane mode, off your internet connection, and open Instagram or Facebook or Amazon. I think Amazon won't work in app, but yeah, you can open your Facebook or Instagram. You will be seeing some post. You will be seeing some post without even internet connection. That is because of some of the data is already present in your mobile phone, and that gets presented there. It's not new data. Already your phone has captured some data. That is called cookies and cache. You can see that data. We try it out after the class if you want. Sir, it was my first project and it. Yeah, sure, Raman. I'll check it. I'll check it. Here, I'm going through some stuff here now. Uh, that is the reason I've been more busy from few days. Even yesterday, full day, for 16 hours, I'm working on something. From morning 7 I started, night 11 I ended. Uh, yeah, I'm a bit busy these days, but I'll review it. I'll review it. Maybe I'm honestly saying uh, today afternoon also I do have some work like in my time. Evening and for tomorrow. Tomorrow completely I'm free. I'll be reviewing all your projects. Tomorrow, that is Friday. I think it is Friday tomorrow. Yeah, tomorrow is Friday, and we don't have class also. Tomorrow from morning to evening, I don't have any work. I'll be seeing your projects tomorrow. So this is yeah, duplicate. What's the difference between array and object since both of them store data? This is the okay. Aditya, have you read our module one? Like because that is if you are asking for the difference, you missed some parts of module 1. Why? Because an object has key value pair, an array doesn't have a key value pair. It has a key value pair internally, but for programming wise it doesn't have a key value pair. Objects have key value pairs. It worked, but if I'm using new device for the first time and it doesn't have any cake memory as it new, then it won't work. Then it won't work, Sajyoti. It won't work. Because without internet connection and without having any catch in the system you won't get anything. But even if the internet is connected, sometimes your Amazon or your Facebook takes 3 seconds or extra seconds. They're reducing that second, that logic, they're reducing that seconds to make it faster for you. So why we get different quiz than given in the module? I didn't get this question, Jugal. So why we get different quiz than I didn't get this. Usually, I don't see that quiz and all. Only I read this. What we say, technical things. Quiz I don't saw. I have not seen it much. So yeah, then moving forward. What how classification of your data structure is classified in two main things. One is primitive, next is non-primitive. Primitive data structures are pure data structures. Remember, this may be asked in interview for fresher roles, and it may be asked in your exams also if you are having exams and all. Satish, could you please repeat algorithm? Again I'll repeat algorithm after this completion of these data structures. Again I'll come to yeah, I'll be explaining algorithm at this after the break. So do not worry, again I'll come to algorithm. No, don't worry about algorithm for now. Let's complete data structures first. After completion of data structures, I'll give you a break. After the break we will see algorithm. I cannot talk about cookies now, Ravi, because that's not about this class. But if you want, I can tell it to you separately or anytime, but not now. Cookies means it just stores some data, metadata into your system. That's it. That is cookies. But yeah, data structures, primitive data structures and non-primitive data structures. Primitive data structures are pure data structures. They're considered to be a very pure data structures. Pure data structures in the sense a number, string, boolean, null, undefined symbol. You all already know this. You all already know what is a number, what is a string, what is a boolean, what is null, what is undefined. Maybe some of you don't know what is symbol. Symbol is nothing but here instead of writing fruit one, I can write something like sim1 or something like sim2. This is called symbols, but it's not needed because JavaScript got updated. It used to be previously like in ES3, I guess. We used to use symbols for keys, but nowadays not needed. Directly you can use this symbol concept. Here now now it becomes a symbol. This fruit 1, fruit 2, fruit 3, internally it becomes a symbol now. So without using symbol, you're automatically using it. Your keys are nothing but your symbols. Metadata is nothing but data for data. Data that tells about data is your metadata. Metadata, you'll usually see it. For example, let me show it to you. If some of you don't know what is metadata, if I write console and if I go to yeah, symbol dot toString tag console. This is a metadata. This is a metadata. This is not for us. This is for the system. This is for the system to understand few things. We have this is the symbol dot toString tag console. It is a metadata. This prototype, this all is can be considered to be a metadata. Metadata in the sense data about a data about a data. So yeah. So if anyone having any doubt in primitive data structures, you can ask me in Q&A, because directly I will. Sir, when we use metadata, we don't use metadata. We as a coders, we don't use metadata. Don't worry about metadata. We don't use them. And that Facebook meta is different. This meta is different. Don't think that and this are same. Maybe some of you may think that Facebook meta is different. The metadata that I am talking is different. So yeah, anyone having any doubt from primitive data structures, you can ask me in the chat. What number, string, boolean, null, undefined symbol. I see no Q&A. This symbol data type is nothing but your keys. Your keys are your symbols. There's nothing much to talk about it. Your symbols are your keys. In like very old time, before ES6 and all came, we cannot write fruit 2. It throws error actually if we write like this. So we used to write like this in brackets. Keys used to be in brackets, but now they have removed it. Function of sim. It acts like a key. It acts like a key. This is a symbol. This is a. It acts like a key. It just acts like a key here. This is a key. Object is non-primitive. Object is non-primitive. You can see here. Objects are non-primitive. I'll talk about non-primitive. So yeah, Jugul. Symbol is nothing but your keys. Your keys. But nowadays we have stopped using them. Instead of using it in the square brackets, directly write like this. This is much more better. So that is your primitive. When you are talking about non-primitive data structures are many. I'll show it to you. Data structures. There is Wikipedia. And some of the LinkedIn messages that I saw was, sir, from where you have learned these concepts, from we are learning from Alphabeta, but from where you have learned these things. I learned from Wikipedia, because at that time in YouTube also those many videos were not there in 2014, 2015 time. So I used to read Wikipedia a lot. It used to be very tough times. But yeah, I'll show you data structures. No, not this list of data structures. No. Examples. How to ask it? Data structures complete list. Yeah, this is what I'm talking about. Once to look at the screen, is it still tough to go through Wikipedia? Yeah, because nowadays our human what do you say, focus span is very less. If you read for 10 minutes of Wikipedia, you will feel bored, because there are no visuals and all. Your focus span will reduce. Usually it gets reduced for us. Whoever, if any of you are using Facebook or Instagram, if you see reels and all, uh, automatically your focus span gets reduced. It is a scientifically proven thing. Your focus span gets reduced day by day. If you read for like 5 minutes or 10 minutes, you lose your interest in doing that work. At that time there was no this kind of things and all, so focus span used to be very high. But even nowadays my focus span was reduced from when I'm compared to that time. Yeah, it will be hard for you to read this Wikipedia content. Yeah, we need interactive content now to make us engaged. So if you see here on the screen, I'll be scrolling down. All you see are different kinds of data structures. See, there are a lot of data structures: rope, scapegoat, self-balancing, splay, fusion, cube, weak, binomial. Lot of data structures. There are many number of data structures. Ah, see, these many types of data structures are there. Mm, yeah, these many types of data structures are there. Now I will ask you a simple question: is it possible, or is it a good idea to learn all these data structures, to learn all the data structures that are present in the world, like present in Wikipedia and all? Is it a good idea to learn all the data structures? No, right? You, no one can read all these data structures. I want to show you a small thing. uh, because of this data structure only, Google Chrome and Google at that time was I'm not able to find it. Is it Minhash? No. I'm not able to find it here. I don't even remember the name now. But what Google does is, like many companies and many programmers, they usually only fix with some few data structures. Like for example, data structure that are widely used are your arrays, linked list, stack, queue, tree, graphs, objects, and all. These are the few data structures that are used by everyone, that are used by everyone, like mostly all the developers use this. But you know what Google does? Google, like, they have some teams to work on this kind of data structures. For example, there will be a team in Google where they will be conducting some tests, they will be conducting a few experiments on self-organizing list. Some other team will do on skip list, some other team will do on unrolled linked list, some other team will do concrete tree list, some other team will do on XOR linked list. In this way, Google and Amazon also does this. What they do is they divide some teams, and the teams will work on some data structures, they work on some data structures. And that is how Google found out about a data structure that helped them in ranking the scales. Like for example, if you open Google now, see, when I'm typing something, are you able to see some search results automatically? Like for example, if I say GOO, for every letter I pressed, I get new suggestions. You see, every letter I pressed, I get new suggestions. This was possible because of a data structure, I don't remember its name. But yeah, Google, when conducting this kind of experiments, they found out that with a data structure, this kind of when a user presses a single letter, we can show them multiple suggestions. They have found out that it is already existing. It is already an existing thing, but no one touched that concept. No one touched that concept. Google was the first to find out, and it used that concept. And that is the reason, if you remember, and in like 2001 and 2005, at that time, uh, Google introduced this concept of when you're typing something in Google, automatically there will be some suggestions coming down. It was introduced by Google, so it was really revolutionizing at that time. But it is a simple data structure thing. They modified small data structure type, and that became a revolutionary thing, and Google ranked up its scales in business. String is primitive in JavaScript but non-primitive in Java. Is it because strings are not considered as an object in? No, no, everything is considered as an object in JavaScript. Yesterday I told you, everything in JavaScript, everything is an object. Everything is an object in JavaScript. Mm. But yeah, here strings doesn't use any other data type. And you may ask me a question, sir, how to differentiate primitive and non-primitive, sir? If a data structure uses any other data structure, it is called non-primitive data structure. If the data structure is using none of the other data structures, then it is called primitive data structure. Example, do number use any other data structures other than number? Say yes or no in the chat. It is fine for me. Like number, string, boolean, null, undefined symbol. Does any of these use any other data structures other than that? Like what I'm saying is, this is an object. In the object, there are strings. In the object, there are strings. So in the object is taking help of strings. Object is containing strings. So it's not a pure one. It is an impure one. But if you take string, number, boolean, null, undefined, and symbol, they are pure. They don't take any other data structures in it. Number means number. String is string. Boolean is boolean. That's it. At if true or false, you write true or false, right? For boolean, like true. This is a boolean. This is not a string. That is a boolean fixed. It cannot be like it is not a string at all. It is a boolean. So these are called pure or primitive data types. Data structure, sorry. Now, what is non-primitive data structure? Your non-primitive data structures, again, it has few more classifications like linear and non-linear. What is linear and what is non-linear? If you think of an array, array goes in a linear fashion, like one after another, one after another, one after another. It goes in a linear manner, in a straight manner. That is called linear data types, linear data structures. What are non-linear data structures? I'll show you something called tree. Do you think is it in a straight line? This is actually a data structure called a tree data structure. Is it a, but just look at the screen and tell me, is it in a linear fashion, like is it in a single line? No, right? It is of branches. It is of branches. So it is considered to be a non-linear data structure. Usually non-linear data structures are not straight. Anything that is not straight is non-linear data structure. Again, in a linear data structure, we have something called static and dynamic. What is static? What is dynamic? Static in the sense very simple to use. They're very simple to use. Like a array. Array, they're not complex at all. They're very simple. They're very cute and they're very simple. But your dynamic data structures have much more functionalities and much more properties for itself, like linked list, stack, queue. They have much more power. They have much more power to showcase. They have more properties. So that is your classification. I already talked about number, string, boolean, symbol. See here, symbols symbols used to be used as keys, but nowadays you no need to use it. Use your normal keys. You have your array set of objects, map set already completed in module 1. Stacks, graphs, this is how they look. This is how they look. This is how a linear data structure look. Linked list and all, stacks and all will be coming to you in the coming classes. Don't worry about it, because there is a complete class dedicated to linked list. Yeah, not here. I think somewhere down. You will be having a complete class on linked list, so don't worry about linked list and all. But no, what is that thing? I'll show you. Unloading. Yeah. This is I'm just showing it to you. I'm not explaining it to you because now is not the right time to explain you linked list and graph. It comes later. But this is of a normal stacks look like. Normal stacks look like a linear data structure. If you see here, like it goes in a neat fashion and all, so it is a linear data structure. This is how a non-linear data structure works. A non-linear data structure like graphs. This is how a graph will look like. A tree, a value, what left branch, right branch. This is how a normal graph will look like. Phew. Hmm. I'll give you some time, like 5 minutes of time. Open your material, answer it yourself. Answer this yourself, like yourself. Click on the answer. You'll get the answer revealed. Uh, think of the answer, and in the meantime, I'll complete this Q&A. String is primitive in JavaScript. Yeah, I've already answered this. Mm, There is this thing. Yeah, Aditya. To be more precise, uh, in your Java, string uses something called methods and all. String is your capital S. I know Java. String is starts with your capital S, means it is a class. It is a method. It is not a pure thing. It is a method. It becomes a method, and it has inbuilt methods and all. Usually, only a class has methods in Java. Only a class can have methods in Java. So that is the reason your string is considered to be a non-primitive data type, because it has something else in it. It has something else in it. But if you take a string in JavaScript, it doesn't have like what to say. It's not a class itself. It is not a class itself. It was inbuilt in Java. It was already inbuilt in Java. Sorry, it was already inbuilt in JavaScript. So that is why in JavaScript it's not non-primitive. It is primitive. And also in JavaScript, data structures are explained in a way. If the data structure is using any other data structure inside it, then it is non-primitive. If it is not using, then it is primitive. According to the definition, your string in JavaScript doesn't use any other data structures inside it. So in JavaScript, it is a primitive data structure. And data types is different, data structures is different when we are talking about it. Is primitive data structures and primitive data is same? Primitive, yeah, we can. It is same. It is same. It is same, Devish. Thus, we are going to cover all these non-primitive data structures in module 2. We will be covering. There is also one more module called advanced data structure. In advanced data structures, you will be learning more about this tree, graphs, and all. But in normal data structures, you'll be learning about stacks, queues, linked list, arrays, and strings. So, how DS is important in web designing? Not for web designing, but for web logic. If data structures is helpful for you in web logic, designing your web logic, your server side business logic. DSM, no, DSM algorithms are there in every language. Every programming language you take, it will be there. It is a universal thing. DSM algorithms are universal. Who asked this question? It's a good question. Uh, Vaishnavi, right? Yeah. It's a very good question. Even I faced it. In Alma Better also, I had the same discussion with Alma Better management side. I had the same discussion because I told you, right, I apply for a lot of interviews, and I go to the interviews. They ask me questions. I do coding challenges and all. Many times even when I started in Alma Better also, like this kind of scenario I faced, where they asked me to share my screen. They put a question there. They give a compiler, their own compiler, their company's compiler, and they ask me to write the code. When I click on the drop down to select the programming language, there was no option of JavaScript. It is true, there is no option of JavaScript. But usually now new companies, startup companies, they started to understand and they started to keep JavaScript in that. But still, there are few companies, but that doesn't show JavaScript as an option. So for that, you need to have a backup language. What is this backup language, sir? Again, Backup language is nothing but your primary. Every programmer does this. Your primary programming language, you have to keep one. That for me it is JavaScript. You have to keep a backup language. Sir, what is this backup language? Whenever your JavaScript is not helping you in some situations, you'll be using that backup language. For example, that interview, you asked me a question, sir, in the company it doesn't ask me for JavaScript, sir. You will be using your backup language. That backup language is best if you keep Java. If you keep Java, not Python, also Java. Why I'm saying Java is because usually for the students and all, I see the demographics surveys and all. Java is still considered to be a good language to get inside a company. To get inside a company. Yeah, I shared with all of you with our batch Aman, but to our new friends I'm just telling this because they don't know. Java is tough when it is compared with JavaScript. Java is tough, but whenever you have some time, try to learn Java. Maybe I think Alma Better also you will be at the end again you will be learning Java in Alma Better because having a backup language will always help you. So that is the thing, and it's a good question. Even one time when this happened to me in 2018, I went for an interview to a company. The nowadays it is in Zoom meetings and all, but in 2018, 2017, we should actually go to the company. We have to wait for the bus, go there. We have to actually attend to the company in formals and all. Inside that, they will be giving a system to us, and we have to write the code in front of them. They'll be looking at us like this. They'll be like sitting beside, and they'll be looking at me like this, and we have to write the code. It used to be very stressful, and I learned JavaScript, and there was no JavaScript. I just simply closed the system and I went off that day. Then I understood the importance of having a backup. So yeah, learn some backup language also. Yeah, if Alma Better allows, I think I'll be teaching you Java too because I have a lot of work experience in Java. No, no, no. It giving you will be writing code on Java, but maybe it happens. Really happens because for HCL, I think I've given the interview. They've asked me questions in Java, but once I went inside the company, once I joined the company, and when the project work started, to me it is in JavaScript. It is in JavaScript. Companies, you know about Indian companies and all, right? They ask us one thing, they make us do work on some other thing. It happens. Yeah, my interview was on Java. They asked me a lot of Java questions actually in my interview. What is multi-threading? What is this thing in Java? Why we use scanners and all. But once I went into the company, my first project was on JavaScript, web development. What's the time now? 56. Okay, I hope all of you have answered your own or to you these things. Okay, now let's go for a break. Syntax are same. No, syntax is not same, Satish. It is different for Java. Okay, let's take a break and let us start with what is an algorithm. Now, okay, what is an algorithm? As I said, algorithm is nothing but the logic, a logic that you how you represent it. How you represent a normal logic. We usually represent an algorithm in two ways. One is pseudocode, and the other is flowchart. I'll show you both. Pseudocode is nothing but the way we write plain English. This is how a typical pseudocode looks like. Sorry, not this. Yeah. Declare string, repeat again, do call this function, display this thing, input, repeat again, while repeat again equal to y, repeat again this equal to. It's just a normal English. Converting your code into a normal written English is nothing but your pseudocode. We call it pseudocode. It's algorithm. In algorithm again two versions. One is pseudocode and the other is flowchart. I'm talking about pseudocode. Pseudocode is nothing but writing your logic in plain English, as I've shown you before. It's in plain English. Then what is this flowchart? Flowchart looks like this. This is how a typical flowchart will look like. Lamp doesn't work, lamp plugged in. If it is yes, then bulb is burned out. If it is no, plug in lamp. If the bulb is not burned out, repair lamp. If it is burned out, replace bulb. This is how a typical flow chart will look like. A normal flow chart will look like. I can see here, this is a flow chart for prime, I think. Yeah, prime. If it is an even or odd, this is how a flow chart looks like. A normal flow chart looks like. Yeah, diagram representation of a program. That's exactly right. Diagrammatical representation of a program. Again, I'm repeating from the starting. Algorithm is nothing but writing your code in a normal English way. In a representing your code. Representing your code is nothing but your algorithm. If I am able to represent this code, for example, let's take algorithm for sum of two numbers. Again, everyone look at the screen. I'll write algorithm for sum of two numbers. And there is no one way to write an algorithm. It's up to you. It is up to you. Oh, already one of our friend shared it. I'll just copy paste it. Why to waste time? This is not by me. One of our friend has sent this. This is a algorithm for doing sum and multiplication of two numbers. See, it is very simple. Like read a comma b, let sum equal to a plus b, let product equal to a star b, print sum and product, stop. That's it. By just looking at this algorithm, I should be able to tell what is the logic they are thinking. They're just doing sum and product. They're doing sum and product. It is very convenient. That is how an algorithm should be. This is an algorithm. And this is called pseudocode. In algorithm, this is called pseudocode. And there is no correct way to write a pseudocode or algorithms. Whatever you write, if the logic is correct, it is fine. It is correct. Have you all understood what is an algorithm now? And if the same code, if you are showing it diagrammatically, if you are showing it in this manner, like this is the start, then sum equal to a plus b, then product equal to a star b, then print. That is nothing but a flow chart, diagrammatical representation. Usually we don't do this. If anyone are reading computer science and all degrees and all, for them it is important. As a programmer, we don't do this. Like this flowchart we don't do, but documentation sometimes we'll be writing pseudocodes. If anyone not understood algorithm or pseudocode, let me know. I'm clearing your doubts because I've already re-explained algorithms and all. Sir, we focus on front end more and little bit back end development. Then you will become a front end developer. Then you will become more of a front end developer. So, sir, I have doubt. I know Java so as main language. Which should I prefer Java? Prefer JavaScript because you will be doing all your web development with the JavaScript only. I didn't understand. Okay, again I'll repeat. Yeah, these steps are pseudocode. These are called pseudocode. This is the complete thing is a pseudocode. Lokesh, you or anyone who have not understood, explain me how you add two numbers. Explain to me. Like I don't know addition. Explain to me how I add two numbers. Algorithm is divided into two things. One is pseudocode and flowchart. Pseudocode is also considered to be an algorithm. Flowchart is also considered to be an algorithm. You can call this as an algorithm. You can call this as also a pseudocode. Both the things you can call it. Lokesh or anyone who didn't understand, or else again I'll repeat. It's very simple. You don't think more and more about it. Don't complicate it. See, algorithm for adding two numbers. Okay. Flowchart plus pseudocode equal to algorithm. Yeah, yes, there is. Algorithm for adding two numbers. Very simple. Step one, start. Okay. Step one, sorry. I'll put comments. Step one, start. Step two, take two numbers. Take two numbers, A, comma B. Okay. Step three, do A plus B and put the value in C. Step 4, print C. That's it. That is an algorithm. This is an algorithm. Adding two numbers. You no need to write it in the same way. If you want, for example, let's say start uh, input two numbers, a plus b, print a plus b. That is also correct. Flowchart is not mandatory, but if you want to draw, you can draw flowchart. Flowchart, if you ask me, like I'll show you. Flowchart, add two numbers. That's it. This is a flowchart. Just draw start, input number one, number two, sum equal to number plus number two, print sum, end. That's it. Very simple. This is a flowchart of adding two numbers, and this is algorithm of adding. Are you able to hear me now? I'll share my screen again. Yeah, yeah. So where I stopped. So yeah, if you are able to convey your logic properly, that is enough. That is an algorithm. This is a pseudocode. If you write it, it is called pseudocode. If you draw it, it is called flowchart. That's it. But we usually don't do this as a programmers. We don't do this flowcharts and all. But we do sometimes to write pseudocode. So we do not use letter. That is where I have not used. One more thing, like one of our friend asked, sir, we do not use let, that is where. So we do not use let, that is where. Here, Pooja, you're asking. This algorithm and flow charts are not fixed to any programming language. They are not fixed to any programming language. ER diagrams are for your Java and SQL, Ravi. Here in JavaScript, we don't do ER diagrams. So yeah, where I stopped. This algorithm. Now answer me one thing. Answer me one thing in chat. With this algorithm, can I code only in JavaScript? Can't I code in Java? Like any programming, can I code in any programming language by using this algorithm? What are your views? By using this algorithm, can I code adding two numbers in any programming language or not? The answer is actually yes. Why? Because if I'm a Java guy, by just looking at this, I can understand, oh, we have to take two numbers. We're just doing plus. Okay. And by using my Java knowledge, I will be writing Java code. If I'm a JavaScript guy, I'll be looking at this algorithm. I'll be using my JavaScript knowledge, and I'll be writing JavaScript code. Here, that is why I'm saying syntax does not matter in an algorithm. You're not writing algorithm for the computer. You're not writing algorithm for the programming language. You're writing the algorithm for a human. For a human. To make a human understand, you're writing an algorithm. You no need to write letter, where, those all not needed at all. You no need to mention syntax. Nothing is needed. Just write it in plain English. Plain English, give it to someone. They will understand the code. Yeah, programming language is just syntax. That is the beauty of algorithm. Algorithm is not for computers. Algorithm is designed, algorithm, with the way you write algorithm, it is for humans. It is for humans. For humans to understand, we have designed the concept of algorithm. But later we will be converting this into a system understandable syntax. That is programming language. So this is also an answer. Pooja's one also. So we do not use lectware or anything here. No need. We have to write an algorithm and flowchart. Even if you see the flowchart, Even if you see this flow chart, nowhere they have mentioned like let where, or is it for a string, is it for a boolean, nowhere they have mentioned it. Why? Because this flow chart is universal. Any programming language can take this flow chart and we can code in it. That is the beauty of pseudocodes and flowchart. It is universal thing. You need to write it in such a way that you can implement that in any programming language. It should not be fixed with one programming language. Did you all get it now? What I'm trying to say? Did you all got the point? If anyone did not understood, let me know. You also understood it. That's good. Yeah. Now, what your algorithm should contain? It should contain defined inputs. Like if you see here, I've said what are the inputs I'm taking. Take two numbers A comma B. I'm defining. I'm defining what inputs I have to take, what outputs I have to give, what outputs I have to give. Definiteness. You have to always maintain this definiteness. Like see, do A plus B and put the value in C and put the value in C. If I remove this and put the value and see, if I write only do A plus B, what I'll be doing with that A plus B? I have to store that value somewhere else, right? That is called definiteness. Define what you're doing. That is your defineness. Finiteness is nothing but, for example, if I can write this in four steps, right? If the algorithm can be completed in four steps, write it in four steps. Don't prolong it. Like instead of writing take two numbers A comma B, take one number A, take one number B, and in the next step do A plus, and in the next step do plus B. Don't prolong it. Make it simple, make it concise, make it good. Next is correctness. Make sure that all of your algorithm is correct. That's what we need to see. Now, your next concept comes with algorithmic analysis. Algorithmic analysis. What is this algorithmic analysis, sir? Now, every program in this world, but how to print? In this algorithm won't print. This algorithm is just you will be writing on a paper. You will not be printing with anything. Here you see print C, right? That the programmer should understand that we have to print it in JavaScript or Java or something else. This will not work. The computer won't understand what this is at all. This is for only humans to understand. You will not you will not run this. The computer will not understand also. If I click on run, it will not understand what I have written. When I say print here, that print C is not for the computer. I'm saying my friend, you have to print C. Then he will be coding that. So that is the thing. Yeah, every program in this world has two things. One is you have to check the program. If I wrote a program, for example, if like for example, if five people are there, they have written in an interview. Let's say in an interview, five of them have written a program, and all of them were getting outputs. You need to pick only two. How you do it? You have five people in front of you, like five candidates. Okay, and the five of them have written a code, and all the codes are correct. All the five codes are getting outputs. For every input you give, there is a correct output. Now, but my higher manager is coming and saying, Manish, I need to take only two. In this five, take only two. Just apologize for the other three. Okay. But same work by using this commands. Here, we will not be writing algorithm here. We will be writing it on a paper. On paper, you no need to write this. In between code, but same work by using commands. Yeah, yes, Jugal. Those are called comments. Jugal. Yeah, we will be writing pseudocode as a comments also sometimes. Yes. One is which less time and space required, shortest. That is exactly right. Now what I will be doing is I'll be checking that five codes. I will check which one is running fast. If for example three persons code is running at the exact same time, like all the three codes are running exactly at 1.08 seconds, then I will check for the space complexity. Then I'll check for the space complexity. Which of these three codes are taking much lesser space? Much lesser space. What is paper? Paper. Paper. Maybe my pronunciation is not good for that. Paper. A normal paper. You'll be writing paper, right? I want to show it to you. Your normal paper. Or else, I think. So yeah, that is how you do your time complexity and your space complexity. So what is that? Time complexity. First, I'll talk about space complexity because that is first. But can you think and tell me which one is more important, space or time? Like from your understanding, which one is more important, space complexity or time complexity in today's generation? Today's generation, time complexity is much more valuable because nowadays no one is caring about space. You have a lot of hard disks, ssds and all. If you open a new Gmail account, you will get 15 GB for free. Google Drive, for every account you create, 15 GB free. So no one is caring about space complexity now. At that time, in olden times, space complexity used to be a big thing because the cost of 1 MB at that time, it used to be in millions. Now 1 MB is nothing. You will get nothing as 1 MB is nothing. So yeah, nowadays we only see about time complexity. First I'll discuss about space complexity. Then I'll be discussing about time complexity. So space complexity is nothing but how the internal memory of your computer that takes to run the code. Usually it is more optimized for games. Like if you play bigger games, like GTA and all, those type of games, Rockstar games usually, like GTA, these kind of games, they take very high space, like 100 GB, 126 GB. They take higher GB, but their performance also, how it will be. We all played it, but some games usually does the same thing in 50 GB. Usually gaming companies think a lot of space complexity, but websites, Amazon, as a web designer, we no need to think much of space complexity. But how, I'll tell you how to calculate this. Calculating part, I cannot teach you right now because it will be a completely different class, calculating time complexity and space complexity. But the best I can do is tell you about what is space complexity, what is this constant, linear and all. But calculating part, I cannot teach you right now because it takes a separate 2.5 hours of class. But it is usually simple. If you see the constant space complexity is nothing but when your input is already defined. When your input is already defined. If your input is already defined, for example, if you see here, let R 1 2 3 4 5 console.log get first element. Every time that you run this code, you will be only accessing only one element here. Only one element. In this kind of code, in this complete input, you will be only accessing one element every time. Now answer me this question. 1 2 3 4 5. The length of this input is 5. But every time I will be accessing only one element. Does it matter if the length is 5 or 10,000? Does it matter for this thing? Does it matter here? No, right? Because we are only accessing one element. With the space is only one. So that is why it is O of 1. It is called constant space complexity. How many times you run the code, it will always be O of 1. Only one element we are accessing. Next, linear space complexity is nothing but whenever you see a for loop, it's a small trick that I'm saying. Instead of calculating here, whenever you see a for loop, it is linear. It is linear space complexity. Always remember this. Whenever you see a for loop that goes from starting to the end of the loop, end of the array or something, then it is a linear space complexity. You want me to zoom? It is already in 125%. Now it is in 150. Okay. So that is what a linear complexity is. Whenever you see something called for loop, and if you see it is going from iterating from 0 to the end of the array, it is a linear space complexity. Why? Because you are accessing every element in the array. You are accessing every element. If you are accessing every element, It matters if your length is 5 or 10,000, because if it is 5, you will be accessing only 5 elements. If it is 10,000, you will be accessing 10,000 elements. Think of 1 billion, you will be accessing 1 billion elements. So here it matters. Now that is all about your space complexity. Have you all understood what is space complexity or not? Did you get space complexity? Have you understood? Not like calculating but and all, like, oh, this is space complexity. Have you got it? Yes, right. So next is time complexity. Time complexity, here we discuss like, how to say in, yeah, for again we'll take this kind of code only, the same code, always accessing the first element, always accessing the first element. For this kind of code, how many times you run? 10,000 times you run, 1 million times you run, always it runs in constant speed. For example, if I run this code, let me show you. I'll run this code now. It is 0.15 seconds. It is exactly run for 0.15 seconds. Now I will change the array. Let's say some rubbish I have typed. Now if I run the code, it's still 0.1 second. Like, that's 75 milliseconds is fine, no matter. But it is still 0.1 second. Even still, I'll give a big array. See what happens. I have given a very big array. If I run the code, still it is, oh, now it has changed it to 0.2, but it should not change it like that. Maybe just for accessing this array, it has taken more time. But usually this is not the case. Let me bring it down. This extra 1 second is to read this array, because this has become a big array. So that is why it has taken that extra 0.1 millisecond. But let me remove this. It's not code fault, it's my VS Code fault. It's my Visual Studio Code problem, not this code problem. Yeah, it's now again 0.1. So what I'm trying to prove is, when even though your input is getting bigger, then when you run this code, it always remains 0.1 or 0.2. Let's consider 0.1 or 0.2. It's almost constant. Every time that you run, it is constant. So that is why we call constant time complexity O of 1. I'll talk about this O of n, O of 1 and all. It is O of 1. Now what is this linear time complexity? Again the same thing. Whenever there is whenever there is a for loop, it is usually will be in linear time complexity. For loops are always linear time complexity. Why? Because you have to access all the elements of the array, and if the array increases, your time also increases. Now I will ask you a simple question. Use your knowledge and tell me. This is normal for loop. This is normal for loop. This is for loop inside for loop. Which one has less time complexity? Which one is better? One for loop or for loop inside for loop? Use your knowledge and tell me. First one, right? Because yeah, this is only one iteration. Only one time you will be going through the loop. But here you will be going multiple times. This time complexity is called n. Remember, this time complexity is called n square. N square. That is n into n, or else you can think n into n. N square. Okay. Now I hope all of you know mathematics. I hope. Like this kind of questions, for each question write yes if the question satisfies the given notation or no. This satisfies word is there, right? If the left side is greater than the right side, then we call it as satisfies. If the left side f of n, if this is what do we say, greater than this n square, then we call it satisfies. Now use your mathematical knowledge, and tell me what is this link. Oh my god. Okay, if you have time you can go through this, but it's up to you. It's asymptotic formulas actually. I've seen this in my BTech times. Now again I'm seeing it. Uh, yeah, yeah. Again coming back. Put it in chat if f of n satisfies this condition or not. O of n. Like just say if this is greater than this or not. If this is greater than this, just say yes. If this is not greater than this, say no. Or else if you feel like I'm confusing you till here, have you understood till this moment? Till this moment, if you have any doubts, first ask me. If till here, till here, if you have any doubts, don't think about this now. Till here, if you have any doubts, ask me. Till this. uh, like I'll go still back. Have you all understood space complexity? Like I'm still going back. Have you all understood space complexity? If not, say no. I don't. I won't say anything. Some saying no, some saying yes. Okay. Again, and space complexity. What is space? All programs. It's all programs. We always do it for all the program, not single variable. All the program. Again, I'm repeating. Okay. Take this code. Uh, no, sir. Proceed. You want me to proceed, Jugal? Oh, okay. You're saying no, no doubts. Proceed. Okay, that's what you're saying, Jugal. But just to make sure, once again, I'll repeat. It's simple logic actually. Even though this, if you see this array, even though the array is very big, but we access only one element. That is why it is O of one. That is why it is O of one. Because even though the array is getting big, we are accessing only one element. That is why it is O of one. Linear space complexity in the sense we are touching every element. Or else think it in this way. Space complexity is nothing but how many elements you are touching. How many elements you are touching. Here in this first code, you are touching only always the first element. You don't care about the second element. Always you are touching the first element. So it is O of 1. Here you are touching all the elements. You are touching all the elements. Because you are doing from for I equal to 0, I less than array dot length, you are touching all the elements. So that is why it is 1 to n. 1 to n. N is the number of elements. N means number of elements. If then n is 5, you will touch 5 items. If n is 10, you will touch 10 items. So that is why it is O of n. The space time complexity also the same thing. If in this code you are only working on this first array. It does if your inputs is 1,000 inputs, it doesn't matter. You are always only accessing one element. That is why the time complexity is always O of 1. Means every time you run the code, the complexity remains constant. It is O of 1. But if you see here, if the number of elements keep on increasing, the time also keep on increases. For example, in this particular code, if I run this code, it has run for 0.108, 0.108. But if I keep on increasing the numbers by something, then if I run the code, it will be 0.155. It will be 0.155. So it increases. Oh, sorry. We are finding for element 3, right? Let's search for 84364. Uh, it increased a bit. Usually it increases, but I cannot show you right now. But if I keep on increasing, I'll keep on increasing it. And let's search for 9648. This is a very small array, but think of a very big array, then you will understand. From 0.1032, it has increased to 0.106. Like that. With the length of the array, the time also gets increased. That's why they said O of n. Because if there are million elements, you need to go through million elements and you need to find them. So that is why it is O of n. It makes sense, right? Because the number of inputs getting increased, the time taken for the code also gets increased. This is just a logic location. In real life, uh, Like we will be usually companies do this to find our code time complexity and space complexity to give a better code and all. So I'll just go by myself if you are feeling this as difficult right now. This is n square plus 3n. This is only n square. Here plus 3n is there. Just think it's a small logic. And here n square plus 3n. This is only n square. This usually comes in mathematics and your computer science degree. As a full stack developers, you don't need this. You don't need this. I cannot move it. Yeah, you won't need is, but here n square plus 3n is greater. 3n is greater, so the answer is yes. For second one, 10n plus 5. Here it is only n. 10n plus 5 is greater. Here 2 power n, 2 power n. They both are not greater, but they both are equal, so it is no. Here it is n power 3 plus 100 n square plus 1000. It is only n power 3, so this is yes, it is greater. Oh, your MSc mathematics. Then for you it will be easy. Then for you it will be easy. A 5 log n is 5 times log n. It is only log n, so this is greater. Again, this thing. Oh, for logarithms, right? 0. No, this is not greater. This is greater, so it is not. Like that, you will be keep on going. Hmm. Now it's time for me to show you a chart. This is the chart. Till in your complete life, you need to remember this. Like in your complete life, even if you got a job, even if you are married, even if you have kids, even if you have become a grandmother or grandparent, you still need to remember this chart. It will be throughout your life. Why? Because maybe your manager, let's say your manager will tell you, Monish, your code is log of n complexity. You should right away know that it is a good one. O of log n means good. Here green color you see, right? This dark green color means good. Your code is good. Your light green means okay. Your yellow orange is fair, average. Your red color here you see, right? It is horrible. Your red color means horrible. Your managers will not come to you and tell you that your code is good, horrible, average. They won't tell you directly. In your face they won't tell you. They will say, Monish, it is complexity of n square. I think you need to change it. You need to understand that n square means horrible, because this is a funny event happened in my real life. My own colleague, like he's a fresh join into the company. My manager in the meeting, he told him that actually his name is Prakash. Prakash, your code is it is giving n square complexity. I think you need to change it. He in return he said thank you sir, like that. He thought he is praising him. He thought that manager is praising him, and in the meeting he said thank you sir. I'll keep the coding in the such a way. And he was saying that it became so funny at that time. But n square means it is horrible. Indirectly the manager is saying that Prakash, your code is horrible, just change the code. So always remember this. O of n, O of log n is very good, is excellent. O of n, O of n log n is okay. O of n square, O of 2 power n, O of n factorial are horrible. You need to change your code immediately. So that is your notation. This is how we talk. Now, I need to tell you one more thing. In notations, there are three things: big O, big omega, big theta. Big O, big omega, big theta. Big O notation means like worst case scenarios. Big A notation is worst case scenarios. Big O omega notation is best case scenarios. Let me check once. Yeah, best case scenarios. Big omega is best case scenarios. Big theta is average case scenarios. Now, answer me one simple thing. When we are talking about a product, is it best to always talk about its best case or its worst case? Like if you are talking about a code, is it best to always talk about its worst case scenario or its best case scenario? Put your views in the chat. Don't think as a programmer, think as you're owning a company, or think as a manager mind. You, best case, is it best case? Okay, if all of you are saying best case, then I'll ask you a simple question. If you're checking your program only for the best case, it goes to production, then what if something worst case happens there? Then what if the worst case happens there? Means you have thought only about the best case scenarios. You, for all the best case scenarios, your code is very good. It went for the production. Now what if something worst case scenario happens? Then what happens? Because you what we say, uh, you kept backup for all your best case scenarios, but you have not kept any backup for worst case scenarios. But think it in the reverse way now. If you only think of your code for worst case scenarios, like if this input is this happens, oh, then I have to do something to handle it. Okay, if the user tries to break my website, I have to do this. If a hacker comes to hack my website, I have to do this. If you think only about the worst case scenarios, then automatically you're creating backups for best case scenarios also. We should always, if you do a code, you should always think of worst case first. You should always think of worst case. So that is a good thing to do, because if you're able to handle the worst situations, then there is no need to think of best case also. You're automatically doing that. So in the programming also, you do the same thing. We always notate our programs with big O notation. You will never see big omega notation, big theta notation, other than for theoretical purposes. You will never see them. You will always see big O notation in throughout your life, because big O notation it notates worst case scenarios. It talks about worst case scenarios. It doesn't talk about best case. It doesn't talk about average case. That is the reason in the chart also you will only see big O notation. O, big O means O. It represents with a O. O means worst case. O means worst case. Now, asymptotic analysis means analyzing your code and giving some notation, giving some value like n log n 1 n square. The process is called asymptotic analysis. That analysis is called asymptotic analysis. I'm just seeing some Q&A now. Functional programming is less time complexity. It depends again. It depends again. We cannot say, no one can say this is less complexity, this is high complexity. Based on the programming, what we say, use case, it differs. Big O, oh, this O means worst case situation. We call it a big O. Big O. Where we use this time and complexity, or this is the logic. We don't use it. Usually companies do this. But as a programmer, if you're able to find out, like I told you, right? If anyone says my code is O of 1, I have to be feeling good because it's an excellent code. So that is the point. Big O means big O notations, worst case scenario. Now, sir, you're always talking about this worst case, sir. But what is this worst case and all? The best example I'll give you. Take a dictionary. Take a dictionary. Okay. Take a dictionary. Now, everyone, clear your mind. I'll tell you what is worst case, best case, average case. Clear your mind. Just listen to me. Take a normal English dictionary. Search for let's say apple. In a dictionary, I don't think apple will be there, but it's a word dictionary. Let's take a word dictionary. Word dictionary. Search for apple, or else it's an English dictionary. Search for the word called amazing. Okay. Uh, Now think of in a real life situation. You have a dictionary with you. The dictionary is in alphabetical manner. The dictionary is in alphabetical order. Alphabetical order. Search for the word amazing. Now, will it be fast? Like if I given you a word dictionary with alphabetical order, and if I asked you to search for the word amazing, uh, will you able to search it fast or not? Answer me in the chat. Where the amazing word will be, in the starting pages of the book, in the middle pages of the book, or at the end, at the last pages of the book, where the word amazing will be there? In the starting only, right? How you usually search for a dictionary? We will open first page, not there; second page, not there; third page, not there. We'll go in a linear fashion. Let's say we have to go in linear fashion. Such linear linear fashion in the sense page by page, page by page, page by page. If you are searching for amazing, that is best case scenario. Best case. Why? Because first page not there, second page not there. Maximum in third page you'll find the word amazing. Maximum third page you'll find the word amazing. Now, if I asked you to search for a word called search for, let's say, zoom, where you will find that word zoom? Where you will find it? In the starting pages or at the end? It will be at the end of the book, at the last page or somewhere. Zoom. That is called worst case, because first page not there, second page not there, third page not there, fifth page not there, 50th page not there, 100th page not there. If the book is containing millions of pages you have to turn. You have to turn millions of pages. That is called worst case. The logic is same. The logic is same. You're try to understand my point. The logic is same. I have given you a book. I told you it is in alphabetical order. I told you to search in a linear fashion. The logic is same, but based on my input, the cases are getting different. If my input is amazing, it is the best case. If my input is zoom, it becomes worst case. What if I give a in between, something like search for multiple, maybe M multiple. Okay. Now where this multiple A B C D F G like that, where M will be there? Somewhere in the middle. It's not in the starting, it's not in the ending, but somewhere in the middle M is going to be. So it is average case. Now have you all understood what is best case, worst case and average case or not? If not, let me know, because still more I cannot explain this. This is the explanation I can give. Amazing. Based on the input, your case is getting different. Logic is same. Again and again I'm saying, always understand what I'm saying. The logic is always same. Book I have given, it is in alphabetical order. I told you to search in linear fashion. The logic remained the same for all the cases, but the input, from the input, if I give amazing, it is best case. If I give zoom, it is worst case. If I give multiple, multiple, it is average case. Now, if I am able to optimize my logic for this worst case, if I am able to optimize this logic for this worst case, for example, let's discuss. Since I'm telling to search in linear fashion, when I given zoom input, it is becoming a worst case scenario. Let's say instead of telling you to search in linear fashion, search let's say search however you want. Now I have changed my logic little bit. I have changed my logic to handle my worst case. I have changed the logic to handle my worst case. Now when I'm saying search however you want, like however you want, you search, not linear fashion. Now when I say zoom, now when I say the word zoom, you will go from starting or you will come from the ending. How you do it? You'll go from the starting or you'll come from the ending. Like you'll start searching the book from the back pages or from the front pages. Obviously, with any common sense, you'll be coming from back pages, because zoom is in ending somewhere. You will be starting to look for zoom. Now suddenly this becomes a best case. Because of a small change in my logic, this worst case has turned into a best case. This worst case has turned into a best case. Now what if I say search from middle? Always start your search from middle. If I say to start search from middle, now suddenly this becomes best case. This becomes best case. this becomes average case, and this becomes average case. So based on the inputs, based on the logic, based on different aspects, you need to change your code. You need to make it better, make it better, make it better. That is the reason you are getting updates for every application. That is the reason when you open Play Store, for every 1 week, 2 weeks, or 1 month, there will always be an update. Even though there is no new features added, but there will be some or the other parts of updates. Because of these reasons, the developer will first give you the version. Next, he will think of different scenarios. If I open WhatsApp, if I click on status and someone suddenly I close it, okay, I need to handle it somehow. Then he starts writing code some one day. The next day you will get an update regarding that. That is the reason you need to think in different ways, multiple ways. That is why they are getting paid high. Phew. Yeah, I told you, right? Best case, worst case, average case. Best case means, worst case is big O notation. It is represented by big O. Uh, sorry. Worst case is notated by big O. Best case is represented by the symbol called omega. Omega. Average case is represented by the symbol called theta. Theta. You will only see it here. You won't see it anywhere. Yeah. O of 1 means constant, O of log n means logarithmic, O of n means linear, O of n log n means linear or log linear, n square means quadratic, n power c is polynomial. You need to remember this. C power n is exponential, and n factorial is n factorial. This one your activity you need to do. So that is all about your data structures and algorithms. Nothing more. So we have learned about your data structures, your algorithms, asymptotic notations, big O and all. So yeah, that is all about algorithms and data structures. I know some of your brains may have fried up. I have come from that stage. I